In this video, we're going to learn what a relative atomic mass, sometimes called a weighted mean mass, is for any given element. The mass of an atom of any element, you may recall, is concentrated in its nucleus. The nucleus is made of protons and neutrons. Each of these subatomic particles has a mass number of 1. The atomic number is the number of protons there are in the nucleus. It also identifies the element in the periodic table. For example, you can use the periodic table to see that carbon atoms have an atomic number of 6, so its atoms always have 6 protons. In nature, 99% of carbon atoms also have 6 neutrons in their nucleus. So, in total, what is the mass number for this carbon isotope? Pause, think, and continue when ready. The answer is, the mass number is 12 atomic mass units. That's 6 protons and 6 neutrons, and the isotope is called carbon-12. So what about the remaining 1%, you may ask? It's mostly a mixture of carbon-13 isotopes and carbon-14 isotopes. These are radioactive. They are used to date objects including human remains from archaeological digs. How many protons and neutrons do you think the carbon-13 and carbon-14 isotopes have respectively? Pause, think, and select from one of the following options. The correct combination was C. A carbon-13 isotope has 6 protons and 7 neutrons, whereas a carbon-14 isotope has 6 protons and 8 neutrons. I hope you got it right. When you look at the periodic table, the relative atomic masses, or weighted mean masses, can be quoted up to 3 or more decimal places. These masses represent the average mass for the isotopes of an element. The larger the relative abundance of any isotope, the greater its weighting. So for anything made up of carbon, including you and I, 99% of that sample contains the carbon-12 isotope. This means that carbon's relative atomic mass, or weighted mean mass, is closer to 12 than it is to 13 or 14, the smaller weighted isotopes. If you think of a seesaw, the larger the relative abundance of a particular isotope, the closer the weighted mean mass is to the mass of that particular isotope. Here's a challenge. There are isotopic masses for uranium, a nuclear fuel, with their isotopic abundances. These are shown below. Which of these isotopes has the greatest weighting, and can you predict the relative atomic mass of a uranium sample? The correct answer is that uranium-238 has the largest weighting, because it is the most abundant. The relative atomic mass, when calculated, is 237.99, very close to uranium-238. In summary, the weighted mean mass of an element is the one that is quoted in the periodic table. It represents a weighted mean, or relative atomic mass, of all the isotopic masses for that element. Where there is one isotope with a larger isotopic abundance than the others, the weighted mean mass for that element is closer to the mass for that particular isotope.